Okay, everybody. Welcome here to these notes. Let's get started. Right. So these notes are called properties of exponents, right? But this time we're doing part number 3. So properties of exponents part 3. So as we've learned, we have the big 6 rules, right? First was the property of 1. Next was the property of 0. Then we did the property of negatives, right? Then we did the product property. Then we did the quotient property, right? Now we're going to do the powers property, right? The powers property. So let's see what the powers property says. So it says when you have a to the power of m, parentheses to the power of n, you get a m times n. So you multiply the m with the n, right? So, for example, if we had, let's do a few examples here. So, for example, if we had x to the power of 2, you know what? Let's do that with this less here. So we have x to the power, come on, Mr. Martinez, x to the power of 2 to the power of 4. So this says you multiply m times n. See? M times n. So you multiply 2 times 4. Just like that. All right? And that gives you x to the power of 8. Look at that. That's one example. Right? Next, we can have numbers here, right? So we have 5 to the power of 2 to the power of 2. Right? So this means, that's a 2 by the way. Let me write it better. 2. This means 5, 2 times 2, which equals 5 to the power of 4. Look at that. Right? One more is we have m, let's see, m for Martinez, to the power of 13, like this. Well, you're probably thinking to yourself, well, what's with m? What's inside the parentheses here? Well, there's an invisible 1 here. Whenever a number or a variable has no exponent, there's an invisible 1. So this is equal to m1 times 13. So 1 times 13, that's easy, right? We get m to the power of 13. And there you go. Right? So that's the first rule under powers property. Right? Next, we look here, and it says AB to the power of m is equal a to the power of m and b to the power of m. Right? So that means this m goes with to a and to b. So let's take a look at what that looks like here. So again, let us do, right? And let's use the AB part. But instead of m, I'm going to do, let's see, 17. Right? So remember that this a and this b have invisible exponents of 1. We have 1 there, and we have a 1 there. So this equals to a 1 times 17 times b 1 times 17. Look at that. So we get a 1 times 17 is 17. B 1 times 17 is 17 as well. And there you go. That's a weird one. 17. There you go. Look at that. So the exponent on the outside distributes, right? It multiplies everything by the inside. Right? So we could do the same with numbers. So we have 3, and then let's say we have b. So 3 squared and b to the power of 5, all to the power of 6. So this means that this 6 is going to multiply with 2, and this 6 is also going to multiply with 5, right? It's like an exponent times an exponent. Power of a power, right? So we're going to get here 3 to the power of 2 times 6, and we're going to b to the power of 5 times 6. Right? So that gives us 3 to the power of 2 times 6 is 12. And we get b to the power of 5 times 6 is 30. There you go. Look at that. Right. So that's the second powers of property rule. Finally, right, let's do this last one here. This is a division. Look, a divided by b to the power of m is equal to a to the power of m over b to the power of m. So again, let us use a and b. A divided by b, but instead of using m, let's use a number, and let's use 8. So just like before, remember when a variable or a number doesn't have an exponent, we add an invisible 1 and invisible 1. So this equals to a to the power of 1 times 8 over b to the power of 1 times 8. So that's going to equal to a to the power of 1 times 8 is 8 over b to the power of 1 times 8 is 8. And there you go. Look at that. Right? There you go. Look at that. One more example here. We have, let's say we have x to the power of 7 over 4 to the power of 2, and that's all to the power of 5. So this means we get x to the power of 7 times 5 over 4 to the power of 2 times 5. See, this 5 multiplies with 7. This 5 multiplies with 7, but it also multiplies, 5 multiplies with 2. So we get x to the power of 7 times 5 is 35 over 4 to the power of 2 times 5 is 10. And there you go. Look at that. And those are the powers property, right? So let's take a look at some examples. So let's knock it out, right? So first thing it says is simplify, right? Your answers should only contain positive exponents. So let's take a look here, right? Let's see exactly what we have. So this 2 does not have an exponent, so I'm going to make a little invisible 1 here, just like this, right? So that means I'm going to distribute -3 times 1, and I'm going to do -3 times -1. So that's going to give me 2, 1 times -3, and n -1 times -3. Well, what does that give me? Let's see. 1 times -3 is -3, so I'm going to get 2 to the power of -3. -3 times -3 is +1, so I'm going to get n to the power, +3, excuse me. Right? -1 times -3 is +3. Now remember though, everyone, this said the answers should contain only positive exponents. So I have to make this -3 into a +3. So remember that there's an invisible, this is an invisible fraction here with a 1 under here, right? But in this case, I'm not gonna put the 1 there because this 2 to the -3 has got to go down here, so that for the 3 to become a positive. So I'm going to draw my line here. This 2 to the -3 is going to come down and become 2 to the +3. And this n to the +3 is already positive, so this is it's going to stay up top like this. And that is my final solution right there. Look at that. That's my final simplification. Right. No negative exponents. No negative exponents. Okay. Let's do number 2. Let's check out number 2. Okay. So again, with number 2, we're going to see that this 3 has a little invisible exponent of 1 here. Let's see. X has an exponent of -1, and y has an exponent of 2, so I don't have to write 1. So let us distribute this 4 here. So we're going to get 3 to the +1. Let me write bigger here. 3 to the +1 times 4. X to the -1 times 4. And y to the +2 times 4. Okay, so let's do them one at a time. So 3 first. 3. 1 times 4 is 4. Now x, -1 times 4 is -4. Now y, 2 times 4 is 8. Look at that. All right. Almost done though. Remember what the instruction said, right? Your answer should only contain only positive exponents, right? So I got to deal with this negative exponent right here. So remember, I'm going to write a fraction line. Now again, I can write a 1 here, but I'm going to leave it blank for now. So what I want to do is I want to bring this y to the -4 down, x to the -4 down, so it could become x to the +4. So I'm going to draw my division line here. Okay. 3 to the power of 4, well, that's already a positive exponent, so 3 to the power of 4 stays up there. This x to the -4 is going to come down and become x to the +4. X to the +4. And this y to the +8 is already positive, so I'm going to leave it up top, just like this. And that right there, kiddos, is my final simplification. Look at that. For number 2. Okay? So, right? Make sure you multiply, right? You distribute each one of those exponents to the exponent to exponent. All right? And you change negatives into positives, right? Okay? Let's do one more. Let's go with green this time. Let's go number 3. Okay? So, again, I'm going to have this -2 have a exponent of 1 here. Okay? So, I'm going to distribute this -4 to 1, to 4, to 2, and to 2. Okay? So, -2. Now, I want to include this negative with the 2, so I'm going to go like this. I'm going to say, go like this. 1 times -4, like that. Okay. Now I included the parentheses because I want to include the -2 is what's multiplying. So I'm going to do x 4 times -4, and then I'm going to do y 2 times negative 4. And then z 2 times negative 4. Okay? So, let's see here. 1 times negative 4 is negative 4, so negative 2 to the negative 4 power. Okay. 4 times negative 4 is negative 16, so I get x to the negative 16, just like that. Now, y, 2 times negative 4 is negative 8. And now z, 2 times negative 4 is negative 8 as well. Okay. Now remember, I want only positive exponents, right? Only positive exponents. So I'm going to draw my line here. I have a 1 down here, right? But for now, I'm going to keep it invisible, just like that. So that's going to give me, right? What is that going to give me? I'm going to write it over here, right? So this negative 2 to the negative 4 has to go down and become negative 2 to the positive 4. So negative 2 to the positive 4. This x to the negative 16 has to go down and become x to the positive 16. X to the positive 16. This y to the negative 8 has to go down and become y to the positive 8. And this z to the negative 8 has to come down and become z to the positive 8. Now here on top, there's no number left. Look. So this is where I had to put the 1. And that right here, kiddos, is my final solution. Look at that. Okay? That's my final solution. Only positive exponents, right? Positive 4, positive 16, positive 8, positive 8, and my final solution. Okay? So these are the kinds of examples you're going to see in your worksheet. So practicing our powers properties, okay, for exponents. So that's it right there. Make sure you took notes. You rewind if you have to in order to follow along. But those are the notes. All right. Thank you for being here.